on the screen there. Here. Welcome to the Ocean Environment Lecture Series. Welcome, Mary. I am Susan Shaw. We've got that, right? Okay. I don't know where this is appearing. Okay. So tonight we want to start by thanking the lovely, wonderful chef of Blue Hill, Diane Bianco, for our wonderful food. And she just does this month after month, and we're so lucky to have Diane. Thank you, and Frank, thank you. And also the Blue Hill Wine Shop for our wines. Yeah. And the fish bowl is still very, very happy and thanking you. And I see it built up tonight. So I want to just talk about the lecture series. You know, we titled this the Rachel Carson Lectures of 2012 in celebration of the 50th anniversary of Silent Spring. And here, 50 years later, this courageous scientist who spoke out to the public, reached the public, she's the first person to talk about the relationship between chemical exposure and human health and wildlife issues, the birds dying. So today we're still trying to speak out, and our speaker tonight, Dr. Carpenter, David Carpenter, is right in the footsteps of this woman, telling people the truth about that exposure and what it causes. And people need to know the truth, and the public wants to know the truth. That keeps us going. And the nice thing is that the lecture series has really gotten attention because of the high quality that we have here. And it's picked up now by a group called Cornerstones in Science. It's out of Brunswick, Maine. They're promoting us in southern Maine, and it's funded through a couple of foundations. But what's happened is the lectures have really hit the airwaves. Maine Public Broadcasting Network has picked it up, and all of our lectures, it was starting with our January one, are being videotaped, and Dylan Post, our video director in the back, is taping this tonight. This will be on MPBN coming up, and all the lectures are available on the archive of Speaking in Maine. So that's quite something, I think. And we have a full lineup for the year of 2012. It's just stunning, the speakers we have, the caliber. We're covering the important topics. The lectures are of anything, or if anything, not boring. And tonight's lecture will be the same. And we've also had an offer by two groups to take 3 or 4 of our top lectures and show them one night here, the next night in Portland. So this lecture series here in Blue Hill is going statewide and region-wide. Thank you. Isn't that wonderful? I think it's just fantastic. This is the lineup for the winter. Some of you heard last month Stephen Coughlin talk about the Penobscot River. Tonight, David Carpenter. On Thursday, March 8th, Dirty Bottoms, the industrialization of aquaculture. This woman is from Canada, Inka Maluski. She is a colleague of mine that I've never met. We are dying to know each other because we are all over this fish farming issue. And as you all know, in Canada, those farms were using pesticides, the pesticide cypermethrin, to get the sea lice off of the fish. And it's a bath. And after the bath, where does it go? They dump it into the coastal waters. So they've had 2 or 3 big lobster die-offs there. And the Environment Canada studied this for a year. They made the link between the die-offs and the cypermethrin dumping by Cook Aquaculture. It's right at the border there. And now the CEO and several people in that company have been fined, and they're being sued. So anyway, after that we have Dr. Fishoff talking about communicating science. Communicating science. Give science a chance. Some things coming up that we're doing that springboard who we are from here out into the world. I've been almost really stunned to receive an award from the Explorers Club this year, and it's going to be on stage at the Waldorf Astoria in front of 4,000 people. It's a Citation of Merit Award, and it's March 17. And then the day after that, I give a talk about the crisis in the oceans and what needs to happen to save the oceans. And the talk is titled The Vostok Dilemma, Time Capsule or Ocean Tipping Point. And the reason for that is that some of you may know the Russians have been drilling for about 20 years in Antarctica to get 2.5 miles down through the ice crust to reach this subglacial lake that's believed to contain ancient life forms and microbes. They're drilling in a dirty way. They're using drilling fluids that are toxic. They are the risk is that when they get to the lake, all these gases that are in the lake will explode and contaminate the whole Antarctic environment and drive climate change and push the oceans further into, deterioration. So it's a high-risk venture. They did get all the way down to the surface of the lake in February, and then the weather closed in on them, so they sealed the whole thing off, left, and coming back in the spring to continue. And the way they're drilling has been criticized by the Antarctic scientific community. So they're trying something tricky to avoid contaminating the lake. And so I'm talking about that in tandem with the drilling we're doing, deep water drilling in the ocean that resulted in the largest environmental disaster in our country's history, which was the Gulf oil spill. And I'm talking about that as a construct to talk about the ocean crisis in general. That talk is open to the public on Sunday. If any of you are in New York, I would like to invite you. Please let me know, and I'll just personally put your name at the door. The night before is at the Waldorf. This talk is at the Explorers Club on East 70th Street. And then the other things, I guess, is that I'm a Woodrow Wilson visiting fellow. I'm going to be hosted at Northeastern University. I'll be there for a whole week, starting on the 26th in Boston, and I'm going to give several talks. And then I'm also participating in this Affordable World Security Conference, which is that week, March 27, 28. We have a video featured there on the Wall of Hope for Ocean Solutions. And so we're just really getting our message out there. And I think, this is the time to do it. These are the opportunities that offer us the chance to do it. And I think it's critical that we do this. Anyway, thank you. Okay, tonight we have the pleasure of welcoming Dr. David Carpenter. He's a good friend of mine, a colleague, a co-author, collaborator. He's professor at the School of Public Health. He's also the director of the Institute for Environmental Health at the State University of New York at Albany. His work has been widely recognized around the world. He won many awards, including a recent grant to do a study of toxic chemical exposure into the villages in the Arctic of Alaska. And he serves on many global advisory boards, including the National Institute of Environmental Health Sciences advisory, the advisory of the Pacific Basin Consortium on Hazardous Waste, Environment, and Health, and I'm so pleased to invite Dr. Carpenter to come up and speak to you tonight. Actually, I want to also tell you that before the lecture, another thing we're starting is a series of conversations between me and leading researchers and scientists. We taped this afternoon a very dynamic, just sizzling conversation with Dr. Carpenter, our first conversation, and those will be posted on our website as podcasts after the lectures and also made available widely to the media. So these lectures are really going to get out there, including your questions. That's going to be part of it. So I think we can be proud of that. And I want to welcome to the podium here Dr. David Carpenter, and it's a great pleasure to have you.
Susan's a great friend, and I've been a friend of Mary for a long time, and I really think that Mary's been doing a wonderful job. And it's an honor to be invited to give this talk. You know, Susan said that we were videotaped this afternoon. When it was over, I said, boy, I was pessimistic. And, you know, what I'm going to talk to you tonight about is probably a little pessimistic, but what I think is the important message is that people need to understand and know what they're eating. And only with a certain amount of knowledge can one choose what you eat, what you do in a reasonable fashion. So I guess I went the wrong way. Some help. I won't use that any longer. Here we go. All right, so the question is fish safe to eat? If you ask the general public, if you ask most people in the medical community, they'll say fish is safe to eat, it's important, you should eat more. What are the reasons that fish is good? Well, fish contain, they're a good source of protein. They are not they don't have a lot of saturated fat, and they have the omega-3 fatty acids. These are the wonderful things that cure every disease mankind has. Now, unfortunately, the evidence that the omega-3 fatty acids are so good for you is pretty limited. What are the bad things? Well, fish contain a number of contaminants. There are two major classes of contaminants. There's methylmercury. This is mercury that's changed by bacteria in aquatic sediments, both freshwater and marine. It gets methylated. Methylmercury can cross into the brain, whereas inorganic mercury can't. And it's known to cause decrements in IQ and heart disease. But they also contain persistent organic pollutants, and I'll talk more about them, or I'll talk a lot about methylmercury as well. These are fat-soluble compounds like dioxins and PCBs and DDT, a la Rachel Carson, and a variety of other chlorinated pesticides. And these are in the fat of fish and other animals, and they get in our bodies. And the question is, what do they do? Well, so the issue is that these omega-3 fatty acids are essential. They're absolutely necessary for human life. We cannot synthesize them. Actually, fish can't synthesize them either. They're made by microorganisms in the aquatic environment. And in the aquatic environment, the little organisms get eaten by the worms, which get eaten by the little fish, which get eaten by the big fish. And these things then rise up through the food chain so that seafood is the major source of long-chain omega-3 fatty acids. Now, I'll come back to that in a little bit. How about methylmercury? Well, methylmercury, the only real route of exposure is eating fish. The mercury that comes out of coal-fired power plants is inorganic mercury. And that's got toxicity, it damages our kidneys. But the real danger from mercury, and this has been the evidence behind a lot of the regulations on mercury release, is that mercury gets into lakes and streams and oceans and gets converted into methylmercury, which gets concentrated in fish and gets in our bodies. The mercury binds to proteins. It's not in the fish fat, it's in the flesh. And how much mercury is in a particular fish is a function of where it lives and what it eats. So carnivorous fish that eat other fish have more than vegetarian fish. Now, there's strong evidence that prenatal exposure to methylmercury reduces IQ in children. Overwhelming evidence. The National Academy of Science has reported on this on numerous occasions. But what most people don't realize is that methylmercury exposure to adults causes problems also. Now, this is results on various indicators on children in relation to their methylmercury exposure. This comes from studies in the Faroe Islands where the exposure is primarily from eating whales. But you see that the higher the methylmercury, the shorter the attention span, the less the visual spatial acuity, and the greater the reduction in memory. And the National Academy of Sciences has concluded that methylmercury causes reduction in IQ. Now, if you're a woman of reproductive age, you can get rid of your methylmercury by not eating fish for about a year. The half-life in the human body is about 70 days. But this, again, from the National Academy of Science, 10% of women of reproductive age in the United States have methylmercury concentrations that will reduce the IQ of their child. And if you had fish the night before for dinner, 50% of women will have levels in their blood that trigger these advisories against, that indicate harm to the child. Now, I've been involved in a study. It's interesting. A wealthy man in New York City thought fish was very safe to eat, ate a lot of fish 3-4 times a week. And he found his hair was falling out, he was getting tingling and numbness, and his brain wasn't working right. And finally, he was diagnosed with mercury poisoning. And so this man funded over $1 million to Stony Brook University to create a consortium, of which I'm a part, to spread the word about mercury poisoning in adults. And these are the symptoms: memory loss, hair loss, tingling, things that maybe you attribute to old age, but they aren't. And at very high exposures, slurred speech, clumsy gait, tunnel vision, decreased visual acuity. I just had eye surgery, so my acuity isn't great, but it's not because of mercury. But then these are just testimonials of individuals, middle-aged and older, even young, where people they ate too much fish. And they found all of these symptoms, mainly nervous system symptoms: tingling, hair loss. I work closely with the woman, Dr. Hightower, who's an internist in the San Francisco area, has a very high-income clientele. And she had a whole series of families coming to her with these problems. The kids were causing trouble in school. They weren't learning well. The women were having hair loss. They were having tinglings. And what she found is that they had levels of mercury in their bodies that were causing all of these problems. They thought fish consumption was good for you, so they ate high-end fish, swordfish, shark, tuna steaks, 3-4 times a week, and they were poisoning themselves. Now, the next project I got involved in, this was a New York City project. There's a random survey of Americans called the NHANES study. And that looked at mercury levels in an average random sampling of Americans. And there were particularly high levels of mercury in New York City. So the New York City Department of Health did a more careful study of mercury levels. And this is what they found, is that there are a whole pile. The average in the US was about less than 10 micrograms per deciliter of mercury in their blood. But in New York City, the average was 25. And among the Asian community in New York City, it was 47. So where does methylmercury come from? It comes from eating fish. So they decided to do a study where they would measure the level of methylmercury, and also they added PCBs, in fish from Chinese markets in New York City. And my lab was responsible for doing both the PCB analysis and arranging for the mercury analysis by a colleague, John Arneson. And this is what they found, that the consumption of fish was very high in the Chinese population. It was high in the non-Chinese Asian population. It wasn't so much higher in the white, the black, and Hispanic population. Actually, the Hispanics didn't eat very much mercury. So the question was, how does this relate to fish consumption? And what they find is the more fish you eat, the higher your mercury level. Well, then they sent to my lab all of these fish purchased from Chinese markets in New York City. Now, we don't really know how many of these fish came from China. Probably the majority of them did not, because you don't import carp from China when you can buy carp in the US. But these are the fish that you find in supermarkets all over the country. And what they found, this slide shows the advisories of, if you eat 5 fish a week, you see that, the striped bass, very high levels of mercury. And for almost all of the fish, some of the fish exceeded the advisory levels. Well, what about pops? Now, this is my personal area primarily of research. People know me for a variety of things, electromagnetic fields and a whole variety of things. But what I do personally is primarily study the effects on human health of PCBs, of dioxins, and chlorinated pesticides like DDT. So we sort of added this on. What are the levels of these persistent organics in these fish from Chinese markets? And I take these Chinese markets to be the same as what you have. I know what your supermarket chains here are. And all right, but you're going to find it in every fish market. And what about PCBs and dioxins? These are known human carcinogens. PCBs and dioxins, like methylmercury, reduce IQ in children if they're exposed before birth or early in life. And they furthermore increase the risk of a whole variety of other diseases. This was my talk this morning at Colby. The relationship between exposure to these chemicals and high blood pressure, cardiovascular disease, and diabetes, the disease that most of us as adults will ultimately die of. So these are pretty nasty things. Well, what concentration of PCBs are safe? My answer to that is 0. Because while it's hard to say what is the threshold of exposure to these chemicals in active disease, they don't have any beneficial effects. They have only negative effects on IQ, on cancer, on diabetes, on heart disease, on high blood pressure, on normal endocrine activity. Now, what does our federal government do about regulating it? Well, the federal agency responsible for telling us what's safe and what's not safe is the Food and Drug Administration. There's some good people there. I have a lot of friends in the FDA. But the FDA has its hands tied. They tried to establish a value for PCBs in fish based on human health effects. They were sued by the fishing industry. The courts ruled that they could not establish safe values based on health effects. They had to consider economic impact on the fishing industry. The FDA has a standard for PCBs in fish of 2 parts per million. And I'll talk about parts per million because PCBs are a mixture of different chemical compounds, so you can't talk about molarity. And that was determined as a compromise between economic impact on the industry and health effects. Now, the EPA doesn't have any regulatory responsibility. There's some pluses and minuses about EPA, but EPA in this issue is a little more independent. They established advisories for sports fisher persons based only on health effects. And I'll show you some of those advisories, and they're much more restrictive than the FDA advisories. Here's the advisory for PCB exposure. Now, FDA has advisories for each individual chemical, but they also have advisories for when you're exposed to more than one chemical. And they give advisories for non-cancer health effects, which says, you know, if you're going to eat a lot of fish and there are chemicals in the fish, what's really important is not what the absolute concentration is, but it's how many fish you eat every week or every month, what the concentration is, and what the risk of diseases is. So they give this advice and they say, well, you can eat as much as you want if the PCB concentration is less than that particular number, 0.0059 parts per million. But notice that for cancer, that number is lower. And this is based on a whole variety of evidence that shows that PCBs cause cancer. And there's a thing called a cancer slope factor, which is based on evidence mainly from animal experiments, that the higher your PCB exposure, the more likely you are to get cancer. So notice a couple of numbers, particularly this one. This is the PCB concentration where you shouldn't eat any. Now this is in parts per million. This is a little confusing because I'm going to talk about parts per billion. But this is about 100 parts per billion. And now look also at 4 meals a month. That means 1 fish meal a week. And that's about 0.1 parts per billion. Well, what are the levels in all of those fish from the Chinese markets in New York City? What the city health department did is use the non-cancer value as an indication. And when I objected in the publication that they were deceiving the public by not talking about cancer risk, they refused to consider cancer risks, and as a result, I refused to have my name on this paper. They said, if we talked about cancer risk, the advisory would be don't eat any of those fish, and people would be so scared that they wouldn't know what to do, and they wouldn't pay any attention to the advisory. Okay, so this, remember what I was saying, in parts per billion, the do not eat any level is 100 parts per billion. And you see, for almost all of these fish, some of them have more PCBs than would trigger an advisory, don't ever eat it. Now the problem is, when you go to the supermarket to buy a piece of fish, there's not a sign that says what the PCB level is. And these are the fish that we all buy in the supermarket. I've already forgotten the other number, but I think the once per week is something like, no, I'm sorry. What was that number? Let me go back. The once per week is 0.01, or that would be 10. So we're down here. Be safe to eat those fish once a week without increasing your risk of cancer. Now, of course, diabetes and heart disease and high blood pressure and interruption with endocrine systems is important. But why not let people know about this? And that I found to be inexcusable. These are other fish. Tilapia is actually a vegetarian fish. Now, granted, it's grown in sewage, but it's a vegetarian fish, so it doesn't have as high a concentration. In 100, the do not eat is way out here. So most of these are not as contaminated. But again, when you go to the supermarket and buy fish, how do you know? Unless you know how different species vary, you'll have no idea. Now, several years ago, I talked about our salmon studies. Susan mentioned those already. And I'm going to show 3 slides of our salmon studies just to make one important point. We looked at contaminants. We looked at 14 different chemical contaminants. 10 of them are pesticides. The other 2 are PCBs and dioxins. And we compared farmed salmon to wild salmon. So the green bars are the concentrations in the wild salmon. The red bars are the concentrations in the farmed salmon. What we found in general was farmed salmon had 10 times, this is a log scale, 10 times greater concentrations of these contaminants than did wild salmon. Now, none of the salmon, if you only looked at PCBs, would exceed the FDA standard. But if you looked at any fish, this is looking at DDT. The more DDT, the more chlordane, the more endrin, the more dieldrin, the more everything. A fish that has high levels of one chemical has high levels of every chemical. So you're not just worried about one chemical, you're worried about the gamish of all kinds of different chemicals. And when we applied the values that EPA gives for how you deal with multiple chemical carcinogens in the same fish, we concluded that the fish from Northern Europe, which were the most contaminated, you could safely eat 1 meal of farmed salmon every 5 months without increasing your risk of cancer. Now, we did find that Northern European salmon were worse than Eastern North America, Western North America, and that in turn was worse than Chilean salmon. And this reflects sort of the history of industrialization. But the point I want to make is while our lab measures PCBs and 3 pesticides, the reality is that contaminated fish contain many different chemicals, and none of them are good for you, and a number of them are really bad. Now, this is recent results from the FDA. This is on dioxin toxic equivalents. Dioxin is what was in Agent Orange. It's a non-human carcinogen, and there's been the development of this concept of toxic equivalence because a lot of chemicals, including some PCBs, all do the same thing. So this is from one study, and unfortunately this study doesn't show meats. But notice that milk, eggs, look at the value in butter. Margarine doesn't have any of these things. Margarine's made from plant oils. Everything that's made from animal fats has dioxin in it. Now look in the fish. Cod liver oil. I hated it as a child. It's hazardous waste. It's pure fat. It's got huge amounts of these chemical contaminants. Striped bass, bluefish, very common sports fish in ocean environments, very high levels. And even sardines, supposedly very good for you. High levels of dioxin. Now tilapia, it may grow in sewage, but it's a vegetarian, so it doesn't have very high levels. Shrimp doesn't have very much. Peanuts have a lot of oil, but they're a plant. They don't eat other animals, so they don't have any. Potatoes and margarine don't have any. Apples don't have any. Eggs and butter and animal products do. Now, I'm not here to tell you to stop eating any animal fat. That's not realistic. But I am here to tell you, know what you're eating and know what the health effects are. All right. The other thing I've been involved with is the Great Lakes. And Maine's a little far away from the Great Lakes, but I've chaired a committee asking the question, are Great Lakes fish to eat for the last 4 years? And our conclusion is no. This is just showing the Great Lakes Basin and what's been happening over time. Now remember, we stopped the synthesis of DDT and PCBs and most of those chlorinated pesticides in the late 1970s. So, we don't make them anymore. They are persistent, which means they don't go away in the environment, and they don't go away rapidly in our bodies. But over time, the levels have gone down. They vary in the different Great Lakes. And this shows, it's a complicated slide, but it's the different lakes, and it shows the concentrations of DDT and its metabolites of PCBs. And notice for both of them, they went down for a while, and then they sort of plateaued. Well, why did they plateau? These things bind to sediments. So the bottom of the Great Lakes are full of these sediments containing these contaminants. And even if we stop putting them into the Great Lakes, there's this reservoir that gets eaten by the worms, by the little fish, by the big fish, and then by people. What's really dangerous is this. These are the polybrominated flame retardants. These are what are in the carpet and the upholstery and this laptop. They're structurally related to PCBs, but they have bromines rather than chlorines. We have not outlawed them. I understand the state of Maine has outlawed products containing these brominated flame retardants. However, nationally, the manufacturers have voluntarily withdrawn production of 2 of the 3 commercial varieties. But we still manufacture and use the 3rd variety. And look at what the levels are doing. They're going sky high in the fish. They're going sky high in human breast milk. They are rising in infant blood. So we haven't learned anything. Now, we haven't studied the health effects of these polybrominated diphenyl ethers nearly to the degree that we have for PCBs and dioxins. But they're pretty much the same thing, and it's almost predictable that they'll have the same health effects. So we've got a real problem there. Now, this is just a table showing that there's a large commercial fishery in the Great Lakes. Huge commercial fishery. Where are we selling this stuff? These fish are contaminated. They're sold in supermarkets everywhere, not just in the U.S., around the world. And yet there's no warning that these fish may contain contaminants. Lake whitefish, very common. This is what your fish sticks are made of. They don't have very much omega-3 fatty acids, but they may have a pile of PCBs and DDT and contaminants. Now, this is looking at people that are sports fishermen in the Great Lakes, and you can see, yes, the levels are falling with time, and that's a good thing. But the question is, at what period of time is it going to take for the fish in the Great Lakes to be safe to eat? This shows PCBs in the Great Lakes, and what you're finding in recent years, the levels have been plateauing. But this level is much in excess of even the FDA level of what's safe to eat. So, Great Lakes fish aren't safe to eat. Many of the fish from the Atlantic Ocean aren't safe to eat. This is the dioxin levels in 3 of the lakes. Yeah, they're coming down, but not very fast. And then remember that the PBDE levels and some of the other newer contaminants are going up at the same time. This is mercury. Mercury is a bigger problem in smaller inland lakes and streams than it is in the Great Lakes, because most of the fish in small lakes are impacted by the mercury that comes from power plants. In marine fish, it's a big problem in certain carnivorous species, more of a problem than in others. And then we have all of these other chemicals that we haven't paid any attention to. Let me talk a little bit about pharmaceuticals. This audience, for the most part, is probably a little too old for birth control pills. But any woman on birth control pills is going to pee out her excess birth control pills. That's going to go in the wastewater. And the wastewater treatment plants do not remove pharmaceuticals. That same is true for antibiotics. It's true for antipsychotic medication. It goes into rivers and streams, ultimately into the ocean. And then we withdraw our drinking water from these same places. Now, we don't really know what the human health effects are. We do know that male fish at the outflow of wastewater treatment plants, all after it's gone through all the treatment, those male fish are synthesizing the protein that female fish make for eggs. Male fish don't normally make them. But because of the estrogenic compounds in that wastewater, the male fish are being feminized. Now, one of the big questions, talking about birth control pills, is what happens to human male infants that are exposed to these things at low concentration. Are they being feminized? We don't really know the answer, but I tell you, it's pretty frightening. Phthalates, these are plasticizers. They're not as persistent as the compounds I've been talking about, but we're exposed to them all the time. I mean, the wonderful food came in tonight with plastic wrap over the top. The reason that's so pliable is it has phthalates in it. BPA, bisphenol A, is present in a lot of hard plastics. But these things don't stay put, they come out. We know that they alter the endocrine system, and the question of how they affect human health is really not clear. I'm going to go back to the omega-3s, because the reason to eat fish, and the American Heart Association, most physicians will tell you, eat fish. You should eat 2 fish meals a week. One should be fatty fish. Well, I don't happen to agree with that, but that is the medical advice. These are essential. We can't make them. They're important for our brain function. They're important to protect against heart disease. About 10 to 20% of all of the fats in our brain are these omega-3s. Now the question is, can you get an adequate amount of those from a normal, healthy diet, or do you have to eat a lot of extra fish that have other things there? Omega-3s are believed to regulate membrane fluidity, and that's a different issue that I'm not going to talk about a lot. But there are a variety of health benefits of omega-3s that have been reported and documented to one degree or another. One is that they reduce the risk of dying after you have a heart attack. Now, pretty clearly they do not prevent the heart attack, but most people after they have a heart attack, if they die because the heart goes into an arrhythmia. And the omega-3s are reported to reduce the chance the heart will go into an arrhythmia. Omega-3s are clearly essential for normal nervous system development. That's not debatable. The question is whether you need to eat more fish or have omega-3 supplementation to have an infant born with a normal IQ. And now there's a whole series of papers coming out saying omega-3s, eat fish to reduce the risk of Alzheimer's disease and it'll cure your depression. It's gotten to be an uncritical advocacy for omega-3s as a magic cure-all for everything. Omega-3s they are immunosuppressive, and they may have some beneficial effects there. But the problem with this is a lot of this literature is uncritical. And when in recent studies that have been a little more objective, they're really finding that, they're not as good as they said they were. For example, the original report said the Eskimos have almost no incidence of heart disease because they eat all of these omega-3s from the whales and the seals and the walruses that they eat. Well, recent studies show the Eskimos have higher rates of heart disease than almost anybody else. Now, what's happened in the meantime from the 1940s when these first studies came out is the fats from these animals have gotten contaminated with all these chemicals. So maybe originally that was a correct conclusion, that it isn't correct now. This is back from our salmon studies. It is clear that the fatter the fish, the more the omega-3s. This shows total lipids against omega-3s, pretty much a linear relationship. The farm salmon, which are the red dots here, red and the yellow, they have more omega-3s than wild salmon. Why? Because they're locked up in a cage, they're fed an indefinite amount of food, they don't get any exercise, so they get fat. But they also get contaminated. So the issue here is to what degree do the omega-3s counterbalance the negative effects of the contaminants? Now, I told you already the omega-3s are important for nervous system function, especially in children. But I think what I've already told you is that methylmercury and PCBs reduce IQ in children. So do they counterbalance each other? What's really important is that PCBs and dioxins cause reductions in IQ. Now I talked about the arrhythmias. I talked about the fact that this doesn't prevent the heart attack. It just reduces your risk. You'll die from an arrhythmia after a heart attack. The American Heart Association still says eat 2 meals of fish a week. But they have a little thing in small print that says be aware of contaminants. I think the American Heart Association is behind the ball on this. And that while omega-3s are important, they should be a part of our diet, one should not be uncritical in accepting the recommendation to eat fish just because they have omega-3s. Now, the big point is that there is no evidence that omega-3s reduce the risk of cancer. They don't reduce the risk of cancer. And if you look at the advisories from EPA, the danger of developing cancer as a result of these exposures is much more serious than the other non-cancer health effects. Now, we've done some studies. This is studies of a Native American population in New York. What we find, now serum triglycerides, this is one component of lipids in our blood. Cholesterol is the other. We find that the higher the PCB level, the higher the triglycerides, the higher the cholesterol, indicating that since serum lipids are the biggest risk factor of heart disease, that this is a risk of heart disease. This is a study, and I don't have the reference on here, but it was a study published in the New England Journal of Medicine by a group from Johns Hopkins University looking at heart disease in relation to fish consumption. And at the top, they looked at the mercury level in relation to the risk of heart disease. And they find that the higher the mercury level, the greater the risk of heart disease. Now, if you adjusted for the omega-3s, the risk was even greater. And now, if you look at the beneficial effect of the omega-3s, yes, omega-3s reduce the risk of heart disease. But when you adjust for mercury, then it's a greater effect. So you have the yin and the yang in the same food. You have the good thing and the bad thing. And the punchline from this story was excessive consumption of fish. The benefit of the omega-3s overpowers, the hazard of the methylmercury overpowers the beneficial effect of the omega-3s. This is studies from Taiwan of children exposed before birth to PCBs. And this is children at the ages of 4, 5, 6, and 7. The black lines are the exposed children. The open circles are the comparison children that weren't exposed. What you see is that these curves are shifted to the left. The higher the exposure to PCBs before birth, the lower the IQ. Now, there's some pretty bright kids that were exposed to PCBs, but they're not as bright as they would have been. And furthermore, there's no recovery with age. This is an irreversible decrement of IQ. And from my perspective, the most tragic thing we can do is dumb down the next generation because we expose them to contaminants. And that's what exposure to PCBs and also exposure to methylmercury does. I think I'll skip this because time is getting on. This is related to diabetes. This is a study from Kate McCaffrey, who was a wonderful woman at EPA who died just recently. But this is looking at the levels of omega-3s in different species of fish against the mercury level. And now EPA has provided advisory saying don't ever eat tilefish, mackerel, king mackerel, shark, or swordfish because they have so much mercury. If you're a woman of reproductive age, If you're older than that, hell with you. But if you're a woman of reproductive age, don't eat those fish. Now, if you look at the fish that have high omega-3s, that's herring, mackerel, salmon. Salmon have very high omega-3s. They also have low mercury, but they have high PCBs and pesticides. Now, let's look at tuna. Tuna is sort of in the middle. There's been a lot of controversy through the American tuna industry because, in fact, white albacore tuna and tuna steaks have high levels of mercury. Now, the light tuna that's cheaper is made from smaller fish, and that has lower levels of mercury. Now, tuna don't have extraordinary levels of PCBs and pesticides, but they have intermediate levels of mercury. So part of the point here is that methylmercury is found in the fish flesh, the persistent organics are in the fish fat. So the omega-3s are also in the fish fat. So a fatty fish is going to have high contaminants, high omega-3s. And the question is, what balances the benefits? So what do we do? Well, from my mind, the first thing is to have some education. Have all of us understand what contaminants do, what fish have contaminants. Now, it's very complicated, but some generalizations. Smaller fish are likely to be better for you than bigger fish. Bigger fish, especially if they're carnivorous, they've eaten lots of smaller fish and they accumulate all the contaminants. Vegetarian fish have fewer contaminants than carnivorous fish. Tilapia is a case in point. But, unfortunately, vegetarian fish usually aren't very fatty, so they don't have as much omega-3s. Some fish have high mercury and low POPs. Other fish have high POPs and low mercury. Salmon is one here, that it has low mercury, but it has high POPs. So there are a whole group of scientists that are focused on mercury, and they say, eat a lot of salmon because they have low mercury. That's true. But they also will give you an increased risk of cancer because they have high POPs. Now, I talked about fish. That was what I was asked to talk about. But I need to make one very important point. And that is these same chemicals are in all animal fats. I showed you a slide that had butter and milk and things like that. I was on a committee of the National Academy of Sciences a couple of years ago on dioxin and dioxin-like compounds in our food supply. And I heard some pretty frightening things there. When a cow goes to a slaughterhouse to make your steaks, there are a lot of waste products, and a lot of that waste is fat. There's no great market for cow fat. So what do we do with that waste cow fat? Well, we put it in the food that other animals eat. Now, cows are not normally carnivorous animals. They eat hay and grass and grain. So we used to put it in cow fat. Now, what that did was recycle all the chemicals that we made 30 years ago back into our food supply. Now, after mad cow disease, the government passed a law preventing us from putting cow fat into cow food. So now we put it in the pig food and the chicken food. And we put the chicken fat and the pig fat in the cow food. And in terms of what it does for the chemicals, they're all recycled in the food we eat. Now, you might ask, why doesn't the government do something about this? Well, economics comes into play. On our committee, there were the hog associations, the beef associations, and they said, well, this is cost effective. It makes the cows grow faster if they eat animal fat. And we could feed them soybean oil, but that's more expensive, and this is going to go to waste anyhow. So, the effect on public health just doesn't get up to the level of attention. Now, there are a variety of groups that give advisories on fish for a variety of reasons. This is one that comes from the Monterey Aquarium. But it says, there's certain fish you can eat quite frequently. Some you should eat once a week, sometimes once a month or less. There's some you shouldn't eat at all. There's some you shouldn't eat because they may not be so contaminated, but they're in danger of being depleted. our ocean fish are in great jeopardy of just being overfished and depleted. Well, the data on which this stuff is based is pretty weak. But I think in general, shellfish are relatively uncontaminated with chemicals. Now, that doesn't mean they don't have antibiotics and other things in them. But, you know, the point is that there are chemicals that are in most seafoods. But again, remember there's also chemicals in your beef, your pork, your chicken, your butter, your milk, unless it's skim milk. Less in vegetables, less in vegetable oils. You know, soybeans don't eat other fish, so they don't have the same exposure to these chemicals. So in summary, I totally agree that fish that's not contaminated is a healthy food. I eat fish, but I try to use some judgment in eating the fish. But fish that is contaminated is a very dangerous food. And the danger goes beyond just being concerned about IQ effects in our children. It goes to the very diseases that most of us will die of. That is cancer, heart disease, high blood pressure, diabetes, disruption of endocrine systems. And the problem is that when you go to the supermarket to buy fish, there's not a big sign that says PCB levels this, mercury levels this. The public just doesn't know. I don't think our government does a very good job of providing information. It's interesting, in California, I'm an advisor to the state attorneys general, and they are considering legislation to require fish markets to provide more information to consumers when they go to buy fish. Most people know about the benefits. Few people understand the risks. And unfortunately, I think the benefits have been oversold. They're real benefits, no question about that. But I think they've been oversold. It's fashionable to think that omega-3s, taking fish oil supplements, is going to cure you of everything. Well, fish oil supplements contain relatively high levels of contaminants. If you take garden variety fish oil supplements at 4 grams a week, which is the recommended value, you will trigger an EPA advisory of do not eat any for PCBs, DDT, dioxin, other pesticides. Now, I think a lot of the fault here belongs to those of us in the scientific community. We haven't gotten this message out. We haven't informed people. Now, it's very difficult to have such a complicated message because you have 2 different contaminants. One's in the meat, one's in the fat. Some fish are higher in one, some fish are higher in the other, some fish are higher in both. It's complicated. But the first step is knowing what the information is. So let me leave you with that. I hope it's not too pessimistic. Are fish safe to eat? Well, maybe. But lots of times, no. Thank you.
I just want to say that if you all think that I'm scary, my colleague, I think, takes the honors here. But I think we have time for a couple questions. Sure, we have questions.
Yes.
You mentioned the omega-3 like supplements, fish oil. A lot of them are advertised as molecularly distilled, no detectable PCBs, dioxins. Do you believe it, or is it true?
Well, it was interesting. I told Susan earlier my story. I went to my internist who said my triglycerides were high and I should take fish oil supplements. So I gave her a long lecture about the contaminants. But on the way home, I stopped and bought some fish oil supplements and tested them in the lab to see what they really had. The problem is, can you believe the advertisement? Now, most fish oil supplements will say mercury-free. I can guarantee you that's correct. Mercury is not found in the oil. It's found in the flesh. So, of course, they're mercury-free. Now, if they really say PCB-free, dioxin-free, the one supplement, I actually brought it back from Japan with me. The one bottle that I found that said PCB free had the highest concentration of PCBs of all the samples we studied. If there is responsible advertising, it is possible to make fish oil that is PCB free. It requires distillation. It requires treatment with activated charcoal to absorb the chemicals. It makes it much more expensive to produce it. And the regulation of advertising is so weak that I doubt that when they advertise it, it's true. But it's not impossible. It's all a matter of cost. Yes?
Are any of the poisons that, like, is it possible to reverse the effects of it? Not necessarily effects, but to get the poisons out of the body?
Another good question. The question is, can you get these things out of your body? The short answer is not really. The only mechanism that has been shown to be a little bit effective, remember the episode where the president of the Ukraine was poisoned with dioxin? He was treated with olestra, the non-absorbable fat that goes right through the gut, and it pulls dioxin and PCBs across the gut the other way. And it does reduce the level of these contaminants. Now, unfortunately, you get a violent diarrhea. You lose all of your fat-soluble vitamins. So it's not very efficient. Now, I have a woman who has been coming to my lab for the last year. She has type 1 diabetes, which has not actually been shown to be related to PCB exposure. But she has gone on a Pringles potato chips with olestra, not a diet, but taking increasing amounts of these. And we have her bloods. We haven't analyzed them yet. I suspect that would reduce your level of contaminants. But again, it's not a simple thing and not something that one would medically recommend except in cases of extreme exposure. You know, the half-life of PCBs is 10 years, whereas for methylmercury, it's 70 days. So this is the big concern. You know, if a 10-year-old girl is eating contaminated fish and gets pregnant when she's 20, she's going to have half of those contaminants in her body, passing them on to her fetus. So, you know, the advisories usually say women of reproductive age or women that are pregnant. Well, that's too late. You have to start with young females. Yes?
Do you think you could make this slide available on the Mercury website
I'd be happy to do that.
of the recommended and non-recommended fishes and whatever?
Be happy to do
That would
that.
be great to have that.
Yes.
I have a
Yes.
question about the tilapia, because about maybe a year ago or so, there was a lot of controversy about tilapia, because I had always thought it was a healthy fish, but the way it's raised, I guess a lot of it comes maybe from Taiwan or somewhere that they actually feed the fish something that makes it very unhealthy.
Well, you know, I'm not so sure that I think tilapia is an unhealthy fish. Actually, I got a question this noon when I gave this same summary talk in Colby. The question is, what are tilapia fed? Well, tilapia tend to be, in Asia, fed feces from chicken farms and pig farms and hog farms and cattle farms. So, you know, but you're in Maine. What do lobsters eat? Just because fish or lobsters eat feces from other animals doesn't necessarily mean that their flesh is contaminated. And I don't see any real reason to say that tilapia is unhealthy to eat. Well, that's another issue, and that's an important issue. Farmed fish, you have fish in a cage, they're densely packed, they're very vulnerable to infections. And bacterial infections are one thing, but fungal infections are even more difficult to treat. So most farmed fish are treated with strong antibiotics and antifungal agents. Some of these antifungal agents are carcinogenic themselves. Now, we didn't study them in our salmon project, but, you know, that's a danger if you're eating farmed fish from anywhere. Now, about half of all the fish you'd find in the supermarket are farmed. And you can be pretty sure they were all exposed to some antibiotics. Now, whether the residues are persistent enough to be in the fillet you buy in the supermarket, I don't know. But again, that's been not very well studied and not very well regulated. Yes?
Do we know what levels are in lobster of mercury and tops?
I'm not aware of any studies that have been done on lobster. My suspicion is that they're relatively low. Again, this is what lobster eats. Lobsters are scavengers. So, if they're eating a lot of dead contaminated fish, they're going to intake those mercury and pops. If they're eating dead seaweed, I wouldn't expect that to contribute very much. But I actually don't know any data from lobster. An important question.
But there's an advisory against eating the pancreatic liver tissue of lobster, the green part of the lobster, because of the PCB levels are very high. There's been an amazing dearth of data about the contaminants in lobster tissue, which I think has been like an absence of funding, of course, but it has to. It's just
it's the main government that's determined not to.
It's the economic, economic determinant, economic ultimatum. We don't know about the flesh. We know, and this is old data, about the PCBs in the what do you call it? Tamale. Yeah, don't eat the tamale is what the state advisory says.
But I would bet on the basis of the other shellfish and so forth that the levels are not nearly as high as they are in carnivorous fish. Yeah. Yes?
Krill oil. It's gotten very popular lately.
I don't know of anyone that's tested it, but krill oil should be the ultimate good omega-3. Because that's the, it's much lower in the food chain. And the higher you are in the food chain, the higher the level of these contaminants. There's a whole industry developing and trying to culture the algae that actually synthesize the omega-3s. Because if you can do that in a controlled environment, you should be able to produce omega-3s that have no contaminants. So krill oil, I haven't tested it, but I suspect it's relatively clean.
The one thing that concerns me about, the popularity of it is all the big fish eat a lot of krill.
Yes.
And they're going to decimate it.
Yes, that's true. Well, some of my studies in Alaska with this UPEC population on St. Lawrence Island, we found the people have high levels of PCBs and pesticides. And one of their major sources is whale oil. They eat bowhead whales. Bowhead whales are filter feeders that eat krill. And we were surprised because we thought they were eating low in the food chain. They wouldn't have high levels of contaminants. But bowhead whales live to be very old. And so there's still something in the krill that if you live long enough, you accumulate enough to be ill. Yes?
What about crab? If the tamale and lobster is, does not are open to eat at this point, what about the tamale and the crab?
I would suspect, again, I don't know of specific studies that have been done, but I would suspect it'd be the same situation as with the lobster. That the tamale, which is basically the liver that metabolizes these things and does store them, would have much higher concentration than the meat. It has a high lipid concentration, and so it would very likely have more than the meat. Now again, crabs, they're scavengers. They're eating dead fish, and they can get contaminants that way, but they're eating a lot of other organic material. Yes?
If frozen fish from a health food store has a label saying wild caught in Alaska waters, would that be reassuring to you? This is not from a supermarket. So.
Well, yes, that would be reassuring. But then, Susan and I have a paper that looked at organic salmon. And what we found was the organic salmon had more contaminants than even the other farmed salmon. So the problem is, can you believe these labels? In clearly wild salmon, at least, are healthier than farm salmon. And that's pretty well generally true. But wild salmon in Puget Sound are swimming hazardous wastes. So it is also a function of where the salmon live, what they eat, what they're exposed to. But I would be, one can't be skeptical of everything. If they say wild Alaskan salmon, I think one has to believe that's true unless you have reason to have specific doubts for those advertisements. Yes?
Yeah, back to the omega-3 in your internists. You feel that you can get the same cardiovascular positive effects from a pure vegetarian omega-3 and hence avoid the risk of a POX?
Great question. There are high levels of omega-3s in nuts, especially walnuts, and some green leafy vegetables. But those omega-3s have only 18 carbons, and only in seafood do you get the longer chain omega-3s. The 20 carbons, 22 carbons are the major ones. Now, it doesn't make a lot of sense to me that 2 or 4 additional carbons would make all that much difference. But there is some evidence that the plant-based, nut-based omega-3s are not as effective as these longer chain omega-3s in reducing the risk of cardiovascular disease. It hasn't been studied so much on the effects on the brain. The human body has some ability to change the carbon 18 to carbon 20, but it isn't very good at that. And this is still debatable in the literature.
What about the grass-fed animals?
Well, grass-fed should have basically no level of contaminants.
I mean, as far as omegas.
Omega-3s, that's the problem. If fish are meat. Well, there is a lot of evidence that grass-fed beef, deer, moose, ungulates that are wild, that are not fed a lot of grain, have relatively high levels of omega-3s. But it's the C18, not the longer chain omega-3s. So now, even if those C18 omega-3s are somewhat less efficient than the longer chain, that is a good source of omega-3s. And very clear evidence that that's beneficial. So one of the problems with our commercial agriculture is that we load these animals up in corn, we get a lot of omega-6s, which are unhealthy. We don't get any omega-3s, and it's just not good. So nature is a lot better than industrial agriculture.
I wanted to ask about shellfish again, the shellfish aquaculture, and we're having that taking place now in farm shellfish along the coast here.
Right.
You I thought, passed over that a little bit, but have there been a lot of studies in the contaminants taking place in the shellfish aquaculture?
Well, there have been some studies. Most of what's been done has been analysis of Asian shellfish, especially shrimp. Shrimp has been the big thing, less on clams and so forth. Now, again, it's a matter of what they're fed and what they're grown in. Most shellfish are filter feeders. They don't eat. They're not carnivorous in that sense. They're taking out microorganisms from the water. But if you put them in a pond that has a lot of PCBs and pesticides in the sediments, of course they're going to take them in. And what is common in shellfish agriculture is you add a lot of antibiotics. So of course they get in the flesh. And there's very little regulation of that. The FDA doesn't hardly test for those things. And again, I'm not saying that FDA is a bad organization. They don't have the resources. They're not given the mandate to really protect us from antibiotics and other chemicals like that in our seafood. But a good question. I think we've exhausted the audience, and I think we've scared them totally away from eating fish.
Thank you. Thank you very much. This is fabulous. Thank all of you. We'll see you here again March 8th for Dirty Bottoms.